Hello guys, hope you all fine. Today we are here to discuss about the size of signal. Here a signal size indicates its largeness or strength, where also signals vary in amplitude over time, and also measuring signal requires both amplitude and duration. A signal number should represent the signal size, and it's very challenging to define a measure of signal that exists over time. And also the next one is signal energy. Signal energy is measure of signal size. It is defined as the integral of a squared signal amplitude over time, and also this measure is positive, avoiding cancellations, and also it is very useful for real value signals. If you observe here, the form is like E is equal to integral of minus infinity to infinity modulus of x of t whole square dt, where the next one is signal power. Here signal energy must be finite to be meaningful, so a signal's amplitude should approach 0 as time approaches infinity. So signal power is the time average of the signal's energy. Signal power is important in understanding signals and systems. For a signal x of t, we define its power as px, which is like limit t tends to infinity 1 by t integral minus t by 2 to t by 2 modulus of x of t whole square. If observe here, this first figure represents a signal with finite energy, whereas this second figure represents a signal with finite power. Let's discuss about some useful signal operations. The first one is time shifting. A time shifting means delaying or advancing a signal by t seconds, which is denoted by phi of t equals x of t minus t. It represents like delaying, whereas phi of t plus t equals to x of t, it represents advancing. Here a positive t shifts the signal to the right, which is delay, whereas the negative t shifts it to the left, which is advance. For example, let's take that x of t minus 2 represents a delay of 2 seconds, and also x of t plus 2 represents the advance of 2 seconds. If you observe here, these three figures represents the time shifting, whereas the next one is time scaling. Here time scaling is the compression or expansion of a signal in time. Compression: if a signal x of t is compressed by factor a, which is a greater than 1, the resulting signal phi of t is given by phi of t equals to x of at. Whereas the next one is expansion: if a signal x of t is expanded by a factor a, then the resulting signal phi of t is given by phi of t equals to x of t by a. Whereas anchor point, the origin t equals to 0 remains unchanged under time scaling. If you observe here, this whole figure, these three figures represents the time scaling of a signal. Whereas the next one is time reversal. Time reversal means rotating a signal 180 degrees about the vertical axis. To time reverse, replace t by minus t, which is like so phi of t equals to x of minus t. Whereas the result is the reflection about the vertical axis, and also the vertical axis is the anchor or hinge. Here reversing about the horizontal axis gives minus x of t, which is different. If you observe here, these two figures represents the time reversal of a signal. Whereas the next one is combined operation. Here x of at minus b is a signal operation that involves time shifting, time scaling, and also time reversal. If a is negative, there are two ways to achieve x of at minus b: by time shifting, by then time scaling, or we can first do time scaling and then we can do time shifting. To get x of a minus tb, x of at minus b, you can time shift to x of t by b units, and then we can scale by a. Here the time shifting moves the signal along the time axis, whereas time scaling compression or expands the signal. Whereas in the time reversal, it will flip the signal if it is a negative, if a is negative. And also, for example, to get x of 2t minus 6, we will delay x of t by 6 units and then compress by 2. This is all about the sum of the interactional part of signals and systems. I hope you understand, guys. Thank you.